Hello learners, today's our lecture is on Unit 7 Physical Infrastructure 2 Roads and Transportation, Energy and ICTs, presented by myself Professor N. Venkateshwarlu, Professor in Mechanical Engineering Department, School of Engineering and Technology, IGNOU, New Delhi, 68. Introduction. The infrastructure services provide the basis for everyday life and enable the flow of goods, information, services within the urban and regional settings. Therefore, robust infrastructure is imperative for maintaining a basic level of services in cities and promoting inclusive growth. In the current scenario, infrastructural management is complex and requires integration with technology to increase operational efficiency and reduce energy costs. Smart infrastructure is therefore the key to improving cities, and it is directly correlated to improving the quality of life of citizens. The key technologies driving the growth of smart cities are connectivity, cloud computing, data analytics, sensors, the Internet of Things and artificial intelligence. So, all these new technologies have been implemented in the providing the better services to the people for transportation, for moving the goods or anything. So, these are all technology, new technologies can be utilized in the smart cities to improve the quality of life of citizens. Objectives. After listening this lecture, you will be able to discuss smart concept for smart transportation for road based transport, understand the intelligent transportation systems technology, describe the smart energy systems in cities, understand the smart grids and smart meter concepts, elaborate on application of information and communication in smart cities. These are the various objectives we are going to learn in this unit as well as in this lecture. First of all, what is smart transportation system? The transportation of both people and goods is of utmost importance in cities. However, with increasing urbanization, population, growing economic activities, there is increased mobility within cities. The traffic management refers to the combination of measures that serves to preserve traffic capacity and improve the security, safety and reliability of the overall transportation systems. Smart mobility. Smart mobility is described as an approach that reduces congestion and fosters greener and affordable transportation options. Smart mobility systems can be applied to mass transit systems as well as individual mobility systems that range from bicycle riding, ride sharing, vehicle sharing and on-demand transportation. The smart transportation systems, for example, the use of Ola and Uber in cities has brought in disruptive concepts of sharing, convenience and mobility within cities through dynamic ride sharing, that is DRS. So, this is already we are using in the cities. Those who are living in the cities, most of the people they are using these services, Ola and Uber services for better transportation in the cities. The smart mobility infrastructure components of multimodal transport are mass rapid transport, multimodal integrated and BRT systems, water transport or freight transport, then aviation, non-motorized transport and smart road networks. These are all the important transportation systems in the city we are using. Then smart road transport management. The smart traffic management is an essential component of smart city initiative, as road based traffic congestion is a severe issue that grows along with city development. Transport especially is a complex issue, as adding new routes in the established urban areas is not an easy option. Resultantly, traffic congestion occurs when the demand is greater than the available road capacity. So, what it says that the smart traffic management, it is very much essential because the cities are growing by population is also growing, the cities because of that the transportation systems has to be improved or the congestion is increasing, but in the same city but the roads new number of roads cannot be developed. So, because of that the congestion is increasing. For that we need to think about other modes or what way we can reduce the congestion. Here intelligent transportation systems, these things we can implement, then we can reduce the congestion in the city. So, what is intelligent transportation system? It refers to the use of information and communication technologies for making efficient decisions related to transport sector. Smart traffic management includes intelligent transport systems with integrated components like adaptive traffic signal controls, highway management and emergency management services. Here the adaptive control technologies or new technologies or intelligent transportation technologies has to be implemented, so that according to the congestion, according to the traffic, it can adjust the traffic lights and it can give the information about the at various junctions, it gives the information, so that how a person can move, that because of that we can reduce the traffic in the cities. To do so, ITS intelligent transportation system uses sensor data, communication and automated algorithms help to keep traffic flowing more smoothly. Central to the smart transportation approach is the development and integration of traffic management measures responses based on dynamic data collection and performance management. The smart transportation systems or intelligent transportation systems in the cities comprises road information monitoring, that is important, then intelligent road lights and signals, then sensors, analysis and accounting of users behavior. These are the components of the ITS, intelligent transportation systems. The entire application of ITS is based on data collection and analysis for traffic management. ITS has a variety of electronic systems incorporating a number of information processing, communication, control and sensing technologies which serve to address different aspects of transportation problems. Components of ITS comprises of network of sensors, different networks, then connected cars, GPS tracked public transportation, dynamic traffic lights, passenger information panels, automatic number plate readers, CCTV systems, navigation facilities and signaling system. These are all the components of ITS system, so that the traffic can be controlled and ease of transportation can be provided. Intelligent transportation systems include a wide range of user support functions ranging from simple information alerts on a mobile phone to highly sophisticated traffic control systems. ITS utilizes a very wide range of enabling technologies, are also known as enabling ITS technologies, which are data processing management and archiving technologies, detection technologies, communication technologies, information dissemination technologies, location referencing and positioning technologies, traffic control and vehicle control technologies, electronic payment technologies, surveillance and conference enforcement technologies. These are all the ITS technologies, are enablers of ITS technologies. Then advantages of using ITS is use a navigation system to find the best route based on the real time conditions, improving the mobility of people and goods by reducing the congestion. So, this is one advantage, and then another advantage is help make effective operations and decision making, alert drivers of potentially hazardous situations in time to avoid crashes, be guided to an empty parking space, reroute traffic in response to road conditions or weather emergencies, increasing safety, reducing traffic congestion and managing incidents effectively. improve safety by providing an advanced warning before potential crash situations, meeting transport policy goals and objectives such as demand management or public transport priority measures. Road information monitoring. Road information monitoring is a prerequisite for any smart traffic control system to understand the prevailing road conditions and patterns. The road networks includes not only traffic and network status, but also expands to include weather and journey time information. Road information monitoring can be categorized into non-intrusive and intrusive techniques. A wide range of different sensors are installed in, on and above the roadway for obtaining the necessary degree of geographical and critical time coverage relating to traffic flow. Intrusive sensors are installed on pavement surfaces. They have high accuracy, but they also have high installation and maintenance costs. Non-intrusive detectors are mounted to the side or above the road surface and typically measure the emitted infrastructure radiation from the road surface. This type of monitoring can serve a dual purpose. For example, units along the road can provide wireless access to vehicles and at the same time collect relevant information with its sensing capabilities. The widely used mobile application like Google Maps or Apple Maps can accurately predict traffic congestion based on the sensor data from monitoring devices installed on the urban roads. All these above technologies represent emergent fields that are expanding rapidly with continuing advances in signal processing. Each technology has its advantages and shortcomings, so the selection of sensor type will depend upon what performs well in the given environmental conditions and its associated costs. Use of sensors in traffic management. Sensor networks play a key role in development of innovative solutions for the traffic management. Different types of sensors can provide different traffic data ranging from point data to continuous path data. The sensors such as acoustic and magnetic sensors are cost effective, power efficient and most popular among the recent vehicle monitoring solutions. Types of traffic sensors. There are different types of traffic sensors are there, that is counting sensors, it is inductive loop detectors, magnetic sensors, etc. Counting sensors, especially inductive loop detectors, have been extensively installed in roadways where they provide point data that includes vehicle counts, presence, occupancy and speed. Using ultrasonic sensors, volume, occupancy, speed and classification of traffic, etc. can be measured. Scanning sensors, which are video detection systems, automatic vehicle identification sensors, etc. The LiDAR, that is light detection and ranging, has become a key component for the evolution of autonomous vehicles. LiDAR enables a self-driving car to observe the world with a few special characteristics such as continuous 360-degree visibility and highly accurate depth information. However, there is a lack of widely accepted standards currently for this technology. Types of traffic sensors, which are road condition sensors, visibility sensors, thermal mapping sensors, noise sensors, wind speed sensors. These are all the various types of traffic sensors. Road condition sensors. A critical component of any road weather information system is a set of road condition sensors that measures surface temperature and moisture and detect the presence and thickness of snow and ice. Road condition sensors can be embedded in the pavements. Visibility sensors are designed to measure visibility along a road section for fog, smoke, dust clouds, heavy rain and snowstorm. They typically use the principle of forward scattering or diffraction of light to detect changes in visibility resulting from inclement weather conditions such as fog, haze and smoke. The sensors need to be carefully sited because they can only provide spot measures at a specific location. Then another one is thermal mapping sensors. These sensors can be used to detect the presence of ice. This is specially applicable for ice formation on the runways of airports in order to improve safety during taking off and landing of the aircrafts. Then another one is noise sensors. Noise sensors measures vehicle flow rate, occupancy and speed by detecting acoustic energy in the form of audible sounds. The sounds are produced from the variety of sources within each vehicle and forms the interaction of tires with the road. Wind speed sensors. These are an essential component of an environmental sensing station and are installed at high and exposed bridges and wind location on the road network. They typically measure surface wind speed and direction and can be used to provide warnings to heavy duty vehicles like freight trucks. Use of Internet of Things for traffic management. IoT paradigm can play an important role in traffic management by connecting the physical devices over the internet to exchange information, tracking and monitoring traffic movement. IoT is instrumental in creating connections between and among vehicles and the transportation infrastructure. So, these IoTs are mostly using for the traffic management because it is an instrument, it is a device which is having various sensors as well as connecting devices, so that it will collect the information and communicate the information wherever required. So, that is the use of IoT devices. Use of Internet of Things in traffic lights. An IoT based real time traffic monitoring system is useful for the dynamic handling of traffic signals based on traffic density. Sensors mounted at strategic places use IoT technology to gather data about high traffic junctions and areas. Furthermore, the CCTV mounted on traffic lights can capture the traffic present on the particular road and transmit this data to the traffic management group. Using IoT, it is possible to analyze the alternative routes using big data analytics for easing congestion. To reduce the congestion, we can use this Internet of Things in the traffic lights. Furthermore, the traffic lights have weather sensor mounted on them. The sensors not only help in adjusting the brightness of lights from time to time, but they also detect unfavorable weather and adjust the lights accordingly. Use of Internet of Things for car parking. So, lack of parking spaces is a challenge in the cities, especially for the bigger cities or smart cities. IoT based sensors in the parking lots can be give out real time information about empty spots in the parking slots. The IoT device, including sensors and microcontrollers, is located in each parking place. Sensors transmit real time data about free and occupied parking place via web or mobile application. So, because of implementation of this IoT technology, the drivers or the owners whoever having the mobile connectivity, they will get the information about the parking lot available. So, accordingly the person can park on that particular place. Another one is use of Internet of Things for the emergency assistance. Road accidents have been one of the leading causes of death across the world. CCTVs and sensors mounted on the roads can help in identifying, locating accident spots and communicating these to the nearest emergency rooms, so that once this communication is established in time, all related emergency responses could be appropriately handled. IoT can help in providing an appropriate way of letting emergency vehicles pass through crowded traffic lanes. Then another one is use of Internet of Things for logistics industry. IoT technology can be applied in the logistics industry as well. Freight goods transport continues to face challenges such as weather, distance, theft, etc. With machine to machine communication and global positioning system capabilities, A vehicle in motion or rest and its contents can be tracked in real time. The most immediate support that can be ensured is efficient monitoring to avoid predictable delays, especially any commercial vehicles carrying perishable or temperature sensitive goods and cargo can be tracked from start to end point, leading to more efficient utilization of the transportation network. Use of artificial intelligence in transport management. Artificial intelligence can be defined as a technology that powers machines with human intelligence as machines having AI capabilities. Artificial intelligence can be applied to traffic management and decision making systems to enhance and streamline traffic management. The application of AI in urban mobility are extensive. Artificial intelligence can adjust street lights, traffic lights, congestion fees, public transportation, parking fee, notifications of parking space availability, and the speed and safety of vehicles and pedestrian traffic. As a result, AI is creating opportunities to make transport safer, more reliable, more efficient, and cleaner. AI models reduce the number of human errors. Transportation analytics assist in minimizing the effects of driving hazards in crowded urban areas, while also monitoring safety regulations compliance. AI applications are already disrupting the way we move people and goods. Artificial intelligence in transportation. Self-driving cars. One of the most groundbreaking application of AI innovation is autonomous vehicles. Autonomous vehicles are fast becoming a reality. Artificial intelligence is vital within these driverless vehicles due to their processing, control and optimization capabilities. Traffic management. Traffic patterns revelation with big data analytics and an AI powered system can help reduce congestion. Delay prediction traffic. The prime transportation disruptor causes delays, accidents and wasted fuel. Prediction techniques however allow you to perform traffic condition forecasting using traffic monitoring data. Drone taxis. Traffic signal control can be self-organizing and adaptable to traffic condition changes by using vehicular adapt networks, network technology and an intelligent control algorithm. So, artificial intelligence and object recognition software can be used to classify objects into pedestrians, motorbikes, emergency vehicles, etc. Such information is then broadcast to vehicles at both roads forming the intersections. In this way, drivers' awareness of the intersection is greatly enhanced, overcoming blind spots and potential upcoming hazards. Smart mobility in Bengaluru, that in India, that's in Bengaluru under the Smart City initiative, the entire transport infrastructure will be upgraded and made user friendly. Roads, payments, public transport, parks and street lights would be upgraded with technology. Siemens Mobility has built a camera based monitoring system for Bengaluru that uses AI to detect vehicles and calculate the density of traffic on the road. So, based on the real time road congestion, traffic lights are altered to ensure smart traffic flow. For example, signals will automatically change according to the number of vehicles along the road in a junction. Furthermore, there are plans to coordinate signals using sensors and factor in pedestrian crossings as well as to ensure pedestrian safety. So, with this students, I hope you understood about the what is intelligent transportation system. In the intelligent transportation system, we use the IoT technologies to make the transportation easy in the cities. For the transportation of goods also, it will make useful by implementing these IoT technologies or sensor based technologies in the transportation system, so that the traffic will be controlled and the the movement will be made easy, and the destinations can be reached in time by providing the information, real time information or dynamic information to the drivers, so that the Ola and this Uber the transportation system, they can give the good services by using this GPS technology or GIS technology, so that they can identify, because of implementation of this IoT technology in the transportation and traffic management, it can provide the alternative ways, so that the drivers can take the passengers in time to the destination by using the less congestion roads. That is one more advantage, and even by implementation of this IoT technologies at road crossings, so it will collect the data about the data about the number of people riding on that road. So the congestion level, the congestion density will be known to the people, so that they can change their direction, so that to reach their place. And sometimes these traffic lights, where in the these snow areas or at the hill areas where the snow is more or fog is more, where these traffic lights can automatically adjust the lighting intensity according to the requirement. So these are the various advantages of these IoT technologies or intelligent transportation systems in the smart cities or wherever the according to the requirement. So even one more example is the parking lot identification. Suppose in the smart cities, the parking lot availability is a big problem in the cities. So a person is entering into a big mall for a for purchasing something, so he has to park his vehicle in the parking place. For that, by implementation of this automatic or advanced technology or IoT technologies, so because of that it senses the data and it will communicate to the concerned person there is in ground floor or in the basement the parking lot is empty, so that you can park your vehicle at that particular place, so that directly you can reach that place and you can park that place. So these are the advantages of advanced or intelligent transportation systems in the smart cities. So here I conclude the this lecture. So thank you very much.